All right. Hi, everyone. This is Ashwin Goyal. I'm taking the session 3 of the Data 101 course. Today, we'll be discussing about statistics and probability. I'll be focusing more on the statistical part, and I'm sure that everyone has done a stats and probability course in either your first year or your second year of your engineering degree. But if not, then I think this lecture will provide you a very brief introduction, and I'll try to cover all the topics that are required in order to become a data analyst or a data scientist. Right. So let's start with the basic classification of statistics. So there are two types of statistics. One is descriptive, second is inferential. The first one, descriptive, essentially describes the data, right? It summarizes the characteristics of a sample or data set. I'll tell you the difference between a sample and a population in just a bit. So a sample, think of it this way. A sample is basically, one part of the data set. And so it describes or summarizes the characteristics of a sample or data set. For example, the descriptive statistics measures can be either a mean or a median, a mode, right, standard deviation or frequency of occurrence of a particular event. So there are two types of descriptives. There are two divisions within descriptive statistics in general. One is measures of central tendency, right? And this includes three types, basically mean, median, and mode. And the second one is measures of dispersion. Now, when I talk about central tendency and dispersion, how are they different? So, what is central tendency? Uh, how is the data distributed around a central value, right? So, let's say this is the distribution of data, and this is the central value. This central value, what is the central value? This is either a mean, median, or mode, right? This might not be an exact center, right? And depends on the definitions of mean, median, and mode. So mode tells me the value which occurs with the highest frequency. Median is just like, the center of the data point, of the data set, because basically mean is when sorry median is when um, we are either taking the average of the first and the last values, and median is a very commonly used measure in, I think, the most commonly used measure in statistics, especially in product roles, right? When product analysts carry out experiments, they base their experiments on median, right? And mean is, of course, the average of, all the numbers that are there. Now, how is median very important? It is basically, when we, let's say I have a data set, I have these numbers, I have one two times, then I have two one time, I have three threes, right? So first of all, this data is sorted, right? And the second is it is sorted either in ascending or descending. Second is that we are essentially wanting to identify what is the middle value. Now, in this case, there are two middle values, right? 2 and 3. And it depends on how we have defined the how we are defining the median. It usually is an average of both of these. In this case, it will be 2.5 in this case. But let's say I have a data set which just has, you know, which has this kind of a distribution. So here clearly the middle value will be 2 and the median will be 2, right? So that way a median is defined, and this is, one of the reasons. Now this gives us an idea, even if, there's I have, instead of this 3, let's say I have 20, suddenly there's a huge increase, right? Even then it will give me an accurate estimate of the middle value. 2.5 is still, the uh, the appropriate middle value for this. But in case I take the mean of this distribution, where the last value after the second 3 is 20, then this 20 will immensely change the mean, right? It will affect the mean in a very disproportionate manner, because I had 1, 2, 3, but then I have 20 straight away. So this will affect it in a very disproportionate manner. On the other hand, the median is, when we talk about the median salaries, or let's say the average placement statistics, we'll look at the median. This is a better indicator because one person might have gotten a 1 crore job and other people might have gotten an 8 lakhs salary package, right? So this 1 crore, if I take the average salary, then this 1 crore will increase the overall average to a very high number. But if I take the median, let's say the median is something like 12, then it will give me an accurate idea. It will give me a fair estimate, a fairer estimate than the mean, right? That way, the median is really important. All right, this is about the central tendency. Now, let's talk about the dispersion part. Again, how is the data distributed around? So I drew this image, right? So how is the data distributed? This part is how it is distributed, this part and this part, right? Around the central tendency, around the measure of central tendency. This can be the mean, median, mode. But how is the data distributed around this central measure? That is that I can understand through dispersion. It can either be the range, maximum minus minimum, standard deviation, and variance. Standard deviation and variance, are so variance is standard deviation squared, and there's a proper formula for standard deviation, right? All right, all right. Okay. So next is the second type of statistics, which is inferential statistics, right? Um, this basically, tries to draw conclusions. Now, descriptive is we are describing the data, and inferences is when we are trying to derive inferences or conclusions from the data, right? And inferential statistics uses analytical tools for drawing conclusions about a population through a random sample. Now, what is this population term and what is this sample term? I'll come to that in just a bit. And there are, a number of methods. I can use linear regression. I can, I can use a number of techniques for drawing conclusions. But two common ones are, first of all, I can estimate parameters that can be related to either linear regression or any other kind of regression. And the second most common one is the hypothesis testing. And I have a separate slide dedicated to hypothesis testing. We'll be covering that in this lecture. All right. What is the difference between a sample and a population? This is the next most important question. So sample and population. Sample is very simple. It's a subset of the population, and we are trying to study the entire population through a small part of it, right? We sometimes it is possible that we are not able to study the entire data set. So population is basically the entire data set, a collection of all the items of interest to our study. That is a population. And sample is a subset of the population, which we study in order to get an idea of the population, right? So that is a subset. Okay, that was the introduction. Second part is a normal distribution. Now, when we talk about a normal, this is the most commonly asked question in interviews. You will have to deal with normal distributions throughout statistics. So there are essentially, when we describe data, we can either say that data is skewed, right? There's no trend or there's no uniform distribution of data. So it is distributed either with a bias to the left or to the right, right? So that can be a general distribution of data, but it is often skewed to the left or the right. And in fact, this skewness is given by the how the data is skewed, right? That shape of the data is either given by skewness or kurtosis. We'll talk about that in the next slide. But you just need to understand that in general, it is possible that the data is not uniformly distributed, right? And the normal distribution is the one in which data is uniformly distributed around a central value, this value, right? So if you see, this data is uniformly distributed, um, and there's no bias to the left or the right. And this is in the form of a bell-shaped curve. right? Pill-shaped curve. Very uniform distribution of data. All right. What are the properties of normal distribution? So this is again a commonly asked question in interviews. So there are some properties which make normal distribution very unique, and these are, first of all, it is unimodal. It has only one mode, right? Which means that there's only one value which has the value which has the highest frequency, the value which is occurring with the highest frequency. There's only one such value. There are no two values like that. So let's say if I have a this kind of a distribution. So here the mode is 3 because 3 is occurring twice. But if I have, now this can be a normal distribution, but if I have this this kind of a distribution where both 2 and 3 are occurring twice, so the mode is 2 as well as 3. So that is not, that cannot be a normal distribution, right? But this can be, there's a possibility that this can be a normal distribution. um, Symmetrical. It is symmetrical, of course. Second property, it is symmetrical. Left and right halves are mirror images. Third is it is a bell-shaped curve, right? And which is this value? This is basically the value which is the highest frequency, right? The value which is occurring with the highest frequency. This is the mode. And this in a normal distribution is also equal to the mean, which is also equal to the median. So this is a very important property of a normal distribution, that the mean is equal to the mode, which is equal to the median, and it lies at the center of this distribution in case of a normal distribution, right? And the third is it is asymptotic. It is not touching the, it sort of tends to infinity. This distribution sort of tends to infinity. I think that is what we are talking about when we think about asymptotic. But yeah, these are the first four are the most important properties, right? All right. So that was normal distribution. Now, since this is the most important topic, we'll talk about we will discuss more about normal distribution. So these are normal distributions, right? They are symmetric about the mean. They are basically distributed symmetrically. They are uniform. So one important property of a normal distribution is that we can observe 68.2% of the variance within sigma deviation, right? So sigma is the standard deviation. What this means is that within sigma standard deviation, within this entire range, right, within this part, we will be able to observe 68% of the variance, which means that we will be able to observe almost 68.2% of the entire data will be lying within this range, within mu minus sigma and mu plus sigma. So from the middle value, which is the mean median mode in the case of a normal distribution, this from here till mu minus sigma until mu plus sigma, within this range, almost 68% of the data will be distributed. Similarly, within 2 sigma from the mean median mode, from the central value, within 2 sigma from the central value, 95% of the data will be distributed. And within 3 sigma, 99% of the data will, the way we'll be able to see 99% of the data. That is an important characteristic. And it is shown here as well, right? Normal distribution. Now we can move to understanding skewness and kurtosis. So, first of all, this is used to describe a distribution. Skewness and kurtosis are two measures which are used to describe or define a distribution. So skewness is the first metric, it defines the shape of the distribution. Now this one is positively skewed and this one is negatively skewed, right? And so here you can look at yeah, since this data is skewed, it can never be normal, of course. And you can look at if it is tilted towards the left side, more data is concentrated towards the left side, right? Then it is positively skewed. And if more data is concentrated towards the right side, it is tilted towards the right side, then it is negatively skewed. Then we have kurtosis, which measures the fatness of tails, right? Because kurtosis can be, positive, normal, or negative again, just like skewness. And this one, if you notice, this has a thinner peak and fatter tails. So this has a positive kurtosis. And this one has thinner tails, right? The tails here of this curve are thinner, while the peak is flatter, right? So this has a negative kurtosis, and the middle one has zero kurtosis, which is normal distribution. Similarly, a normal distribution has zero skewness. It is neither positively skewed nor negatively skewed. I think this is simple and clear to everyone. All right. Next topic is hypothesis testing, and this is where uh, you know the job of product analysts also comes into picture. Many times they do this hypothesis testing, and statisticians deal with hypothesis testing a lot. So it is nothing complicated. It is basically, when we are testing some hypothesis. So it is a method of statistical inference which is used to determine a possible conclusion from two different hypotheses, right? So I think something I decide that, okay, this will be the value of something, and that is my hypothesis, right? A second hypothesis or an alternative hypothesis would be that that is not the value of that particular thing. For example, let's say mean return is equal to 8% for a mutual fund. I think that the value of mean return for a mutual fund is 8%. That is the null hypothesis, the main hypothesis, right? But an alternative hypothesis would be that the mean return is not equal to 8%. So if you notice, this is mutually exhaustive. Together, this constitutes of the complete set, right? So these are two exclusive and exhaustive sets, right? So basically, if I draw this in set notation, this would be set A and this would be B, and together they would constitute the entire sample space. So the hypothesis which was earlier thought to be true or was accepted earlier, this is null. And the hypothesis which we want to test, so we test the alternate hypothesis and is opposite of null, right? It is almost always the opposite of null and attempts to disprove the null hypothesis. Another example, employee candidates who have a minimum of 4 years of work ex are more likely to receive an interview. What would be the alternate hypothesis? It would be that employee candidates who either don't have a minimum of 4 years of work ex, right? Or you can say that employee candidates with no work experience receive, the same number of invites, right? So employee candidates with no work experience receive as many interview invitations as those with a minimum of 4 years of work ex. So this is an example of alternate hypothesis. What are the steps involved? So first we state the hypothesis, both null and alternative, right? We state the hypothesis, then we formulate an analysis plan. Now, what is this analysis plan? It tells us, it gives me an idea that how will the data be evaluated, what all tests I will use, or let us say I'll calculate the p-value or whatever I'll use some formulae, or I'll analyze the data, and I'll make the plan in the second step, and then I'll carry out the plan and physically analyze the sample data. Once I analyze the results, and once I analyze the data, I'll be able to get the results, and based on the results, I'll be able to either reject the null or accept the null, right? Either reject the null hypothesis or state that the null hypothesis is plausible. Now, this is all about hypothesis testing, and we are essentially just identifying whether we can accept the null hypothesis or we can reject the null hypothesis. That is what we intend to do here. Okay. Now the next concept here is type 1 and type 2 error. When we talk about cancer treatment, or let's say when we talk about very practical healthcare related examples, Then we talk about type 1 and type 2 error a lot. Someone might be COVID positive, but uh, you always say this, right? That you might have been declared COVID positive, but you actually might not be COVID positive, or you might have wrongly declared COVID negative, but you might not be COVID negative. You might be actually COVID positive. So that is where type 1 and type 2 error come into picture. So if the null hypothesis is true and we accept the null hypothesis, then it is called as a true negative, right? Which means that if the null hypothesis is true and we accept the null hypothesis, then it is a true negative, right? It is the correct decision. We have correctly identified that it is, that you are COVID negative, let's say. Similarly, if it is true and you have rejected it, then it is a type 1 error. There's some error. It is a false positive, right? So basically, if you look at it in this table, so if null hypothesis is true and you have rejected it, it is a type 1 error. It is a false positive. Just need to remember the definition of type 1 and type 2 error. So type 2 error is when we have accepted the null hypothesis, but it was actually false, right? So that is null hypothesis. And one second. All right. So we were talking about for type 2 error. So type 2 error is when null hypothesis is false, but we have accepted it, right? We should not have accepted it. It was actually false, but we have accepted it. So that is an error. It is a false negative, right? It is a false negative. When I talk about true positive, this is the correct decision. It is when I have rejected the null and it was actually false. So it was false and I have rejected it, which is correct, right? So I've done the correct thing here. All right. Then we talk about linear regression. Now, linear regression is again in statistics. It forms it is a very fundamental concept, and it forms the basis of some machine learning algorithms as well. So it is a linear regression analysis is used to predict the value of a variable based on another variable, right? So I'll show you some graphs. The value that you want to predict is called the dependent variable, and the value that you are using to predict this dependent variable, that is called the independent variable, right? So let's say y is equal to a plus bx. Y is equal to a plus bx. So we are trying to predict y using parameters a and b, and x is the independent variable, right? That is linear regression. There are some assumptions. Again, this forms an important interview question which I have been asked in one of my interviews as well. What are the assumptions behind using linear regression? So first one is there is a linear relationship between x and y, right? This is the assumption. And so y is the dependent variable, x is the independent variable or the regressor. And then errors or residuals are normally calculated. So this is only true if the errors of the data distribution, let's say, this is my data distribution. So the errors should be normally calculated. The error or the residual of the data, the residuals and errors, you need not focus on what is the residual of the data distribution or the error of the data distribution. Just memorize this for now. We'll talk about this when we discuss the machine learning concepts, right? This is this is an example of a data distribution and a linear regress with a linear regressor. Now this is the line that is depicted by y equal to a plus bx. So y equal to a plus bx is this line. And this is the line of best fit as well. Now these data points are distributed in this manner, right? And it is somewhat linear. If you notice, this distribution is somewhat linear. And this is the line which best captures the data distribution, right? So this is y and this is x, dependent variable and independent variable. All right. Now there are two important concepts, p-value and r-squared. So what is a p-value? This this is a slightly I would not say a complex topic, but this is slightly difficult. So you might not get it in the first in the first read, but try to understand. So a p-value is a measure of whether something occurred just by random chance. Right? It is a measure of the probability that something occurred just by random chance. So there was an observed difference. What was the probability that this observed difference occurred just by random chance? Right? And if this probability is low, it means that this difference did not occur by random chance, right? It did not occur randomly. There was some meaning associated with it, right? There was some significance associated with it. And that is exactly what's written in the second part. The lower the p-value, the greater the statistical distance significance of the observed difference, right? The observed difference is statistically significant. There's some significance of the observed distribution, right? So that is p-value. What is r squared? So r squared is essentially, let's say I have two sets, right? Now these sets have a very minimal overlap. So the second set does not capture the variation of the first set very well. But if I have two sets like this, right, almost 100% overlap, this would have a high R squared value because this captures the second set captures the significance of the first one almost very precisely. So almost accurately. So this R squared term, this is uh, commonly used in data science. It indicates how much variation of a dependent variable is explained by the independent variable in a regression model. So how much variation of one data distribution, or let's say how much variation of a dependent variable is explained by an independent variable. So I'll show you this graph. So if you see here this is the the car speed versus occupancy, which is the percentage section occupied by vehicles. This is the bike speed and this is the rickshaw speed. So for the rickshaw and bike and car, we have different R squared. And this line, which is the line of best fit that I told you that we'll get this line through linear regression, y equal to ax plus b. Sorry, y equal to a plus bx. So this line captures the variation of this data distribution, right? It captures the variance, but it does not do so very well. It is, if you notice that this line is probably not the best line that we'll get to describe this data. But this line, this line basically captures the distribution of the bike speed better, right? So R squared value is this. And similarly, this is better than the car speed one, but it is worse than the bike speed one. It again captures the distribution of this data, but it is not capturing it very well, right? So basically, think of it this way that this is the line. There is one linear, there is one straight line which captures the distribution of data, right? And how well it captures that distribution of data, that is deciphered by, that is given by, or that is defined by R squared, right? This is the data, these are the data points, and this is the line. So I think this makes sense. R squared is always between 0 and 100%, obviously. If the data is display, if you have this kind of a thing that all the data points lie on the straight line, then R squared would be 100%, right? Or in if I show this in set notation, these would have a 100% overlap, right? Now this is not a 100% overlap, but yeah, you get the point. So there would be a 100% overlap. That would be in the case when R squared is 100%. And zero is when, these are two disjoint sets, or let's say none of the data points lie on the straight line, that kind of a thing. All right. So this is linear regression. All right. So we'll cover other concepts in the next lecture, which we will cover some extra concepts. We'll also talk about probability. We'll cover that in the next lecture. Thank you, everyone.